Welcome to Study Loop.
In this problem, we have a simply supported beam AD with a uniformly distributed load and an applied load. We want to draw the shear and bending moment diagrams and determine the location of the magnitude of the maximum bending moment. Okay, so now we've drawn the resultant load from the uniformly distributed load and the applied load. Now they are acting at the same point here. And when we consider the 300-pound applied load as a couple, we will change its location. But for now, we've got our four forces, our uniform load and our applied load, and our two reaction loads. Okay, so we will sum our moments about a point A and set them equal to 0. We've got a minus 2400 resultant, an arm of 4. We've got the 300 applied, an arm of 4. And we've got our reaction at D with an arm of 8. Right, and if we solve that for reaction at D, we get that equal to 1,350 pounds. Now we will sum our forces in the vertical direction, set them to 0. We've got an RA minus 2,400 minus a 300 plus a 1350, and we get for our reaction at A is also equal to 1,350 pounds. Now we're going to consider, when we look at our shear and bending moment diagrams, we're going to look at this force couple, and we're going to look at it as a couple acting at the 0.6 feet from A. So it'll have a 600, right? So it'll act as a couple of 600 pounds per feet, and it will act as a force of 300 here. Okay, now we can use our reactions and our applied load to draw our shear diagram. So we're going to start at 1,350 reaction at A, and it will have a negative linear slope until we reach our applied reaction, applied load. We'll have this applied load and more uniform load until we reach our reaction at D. Okay, and so we're going to cross the axis here at 4.5. And so the areas for our shear diagram will have 3,037.5. This triangle here, minus 337.5. This rectangle here, minus 1,500. And this last triangle, an area of minus 600. Okay, using that, we can draw our moment diagram. So it will start out at 0, and will be a parabola, and reaching our peak here and then starting to descend. And we'll have a discontinuity in our moment due to our applied load, our force coupled system. So it's going to decrease by 600, and then it will go back down to 0. Okay, so the peak, so we'll use this area, the positive area in our shear diagram will be the maximum of our moment. So we'll get this peak at 4.5, and 3037.5 will be the maximum for our bending moment. All right, so M max, and we'll give that 3 significant figures. So we get 3.04 kip feet, and that will be 4.5 feet from our point A.